part of presentation, I will present you shortly about the project, present you project activities that were implemented, and say something about the methodology and results obtained during the project implementation, and also discuss something about our present work related to the shallow geothermal energy in Croatia. This full name of the project is Research and Promotion of Use of Shallow Geothermal Potential in Croatia. It is EU-funded project. Its value is slightly above €500,000. Grant beneficiary is Faculty of Mechanical Engineering and Naval Architecture. Our partner is our group of geological experts from Croatian Geological Survey, and the goal of the project was determination of thermal properties in 8 different geological locations in Croatia. Those locations were supplied by our associates, which include 6 technical high schools and 1 institute. During the project, we implemented a so-called distributed thermal response test using fiber optic cables, a method in this area first proposed by Professor Fuji, later adopted by various research teams in Europe and world, significantly most by Mr. Jose Acuna, who was our consultant on this project. As you can see, 8 locations are separated and placed around Croatia, so we can cover Pannonian Basin and the Dinaridic part of Croatia that differ significantly regarding to geology. Basically, project can be divided into 3 stages. First one was drilling works and installation of a borehole heat exchanger. Second phase was determination of thermal properties of the underground, and in the last phase was installation of ground-coupled heat pumps on all locations, so we can have demonstrational systems on various places in Croatia. All locations were equipped with double U-pipe borehole heat exchanger. All boreholes were grouted with GeoFisher grouting material, and before installation, fiber optic cable was placed inside one of the U-pipes of the borehole heat exchanger. This is the schematic drawing of its position inside the pipe, and this is fiber optic cable before the welding of the U-pipe bottom. All boreholes were deep 100 meters, except on our location in Zagreb. On our faculty location, it was 130 meter deep, and we also installed 2 additional fiber optic cables, which I'll explain later. You can see here core samples that were collected continuously during drilling procedure. Upper 4 are from Pannonian Basin, where sedimentary ground formations are dominating, and on the lower part you can see Adriatic carbonate platform and different type of rocks that can be found underground. Determination of ground thermal properties was done using 3 different methods: conventional thermal response test with GeoEnergia TRT unit, distributed thermal response test using fiber optic cables and AP Sensing's DTS instrument, and our partners conducted direct measurements in laboratory and on field on collected core samples shown on slide before. As far as the distributed thermal response test, we separated 3 different phases. In first phase, we obtained undisturbed temperature. In second phase, it was the heating phase, where we monitored the response of the underground borehole heat exchanger, and in the last phase, we monitored borehole thermal recovery. Basically, that allows us to obtain disturbed and undisturbed temperature profiles in the borehole heat exchanger, and therefore we were able to determine vertical distribution of ground thermal parameters on all 8 locations. Here you can see on the first location of the project was in Osijek, around 1.5 hour drive from Beograd. We can see on the left side undisturbed temperature profile. Average temperature in the underground was around 15 degrees Celsius. And on the right side, we can see fluid temperature distribution inside the borehole heat exchanger in 2 different phases of the thermal response test. Also here is plotted the average fluid temperature inside the borehole. This is the fluid entry, and this is fluid outlet. By using the data obtained in first 2 stages of thermal response test, we are able to determine vertical distribution of thermal properties. Depending on the ground layer's content, the thermal properties can vary more or less along the depth of the borehole heat exchanger. Here we have two locations. One is Zagreb, capital city in the central part of Croatia. Another one is Poreč, located on the western part of Croatia, facing Italy, basically on the Adriatic coast. We can see also that variation of thermal properties along the depth can be significantly different based on the layer content. Third phase is monitoring of the ground thermal recovery. It is very interesting because that phase gives insight in the heat transport in the underground. Here are the results from the thermal recovery on location in Zadar. These green dots, or small triangles, represent the first second of the thermal recovery. Going from right to left, we observe cooling of the underground until it reaches undisturbed state. What we can see here is sudden drop of temperature along the 16th meter, indicating that increased heat transfer occurs in this region. If we plot the obtained thermal conductivity, we see that there is unphysically high value of thermal conductivity found there, indicating that actually there is increased groundwater flow that basically results in convective heat transfer that is not covered by a line source model used to obtain this data. If we compare the TRT data and distributed thermal response test data when excluded sections with convective heat transfer, those are those 3 or 4 layers, the difference is around 1.3 watts per meter Kelvin. Oh, sorry. If we observe all locations that were used during the project, we can clearly divide the Croatia in 2 parts, one belonging to the already mentioned Pannonian region, and other one so-called Dinaridic region that is based on the Adriatic carbonate platform. By observing the values obtained, we can see that in the Dinaridic region, thermal conductivities of the underground are slightly higher than those found in Pannonian region, and also the undisturbed ground temperature is highest in the localities located on the Croatian Adriatic, in the Adriatic region, while in Pannonian region, undisturbed ground temperature is basically constant around 15 degrees Celsius. This is area that was represented by lower 4 core samples that were mainly different kind of rocks found on locations. Present work includes equipping all associates, which I already said are mostly technical high schools, with demonstrational units and with heat pumps using digital scroll compressor that are reversible, so they can be used in cooling and heating, and will be used as demonstrational educational systems in those high schools, so we can basically have sustainable project and further education of those who will become engineers or technicians in the field of shallow geothermal energy and heat pumps in general. This was Croatian product from Croatian company Frigo Plus. On our location, I already said that we have drilled the borehole heat exchanger up to depth of 130 meters. Propane geothermal heat pump was installed. It is reversible on the water side. That is slight difference in comparison to those supplied to the high schools. Also, I already said borehole heat exchanger is equipped with 3 fiber optic cables, one placed inside U-pipe, one placed on the outer surface of the polyethylene pipe, and one placed on the borehole wall. Therefore, we are able to monitor temperature distribution along the depth and along the cross-section of the borehole heat exchanger. And also, whole system will be equipped with monitoring and acquisition equipment. So basically, we are able to monitor supplied and extracted thermal energy from the ground and one delivered to the conditioned spaces. Also monitor refrigerant pressures in the heat pump and monitor temperatures of in the heat pump system, in the borehole heat exchanger, and in the distribution system for the cooling and heating. And that will enable us determination of seasonal performance factor in various modes of operation. This is schematic diagram of our system. Borehole heat exchanger installed, heat pump was connected. A few days ago, we have completed the installation of the fan coils and distribution system. In days to come, we will install electricity and connect all the components and basically run the system for the first time, basically by the new year. Also here we installed compact heat exchanger because since the heat pump is reversible on the water side. We wanted to prevent the glycol and water mixture to enter the condition spaces, because since we have around 150 liters accumulation, we would need a large amount of glycol, and that was something that was not very affordable. So basically that is the system that we will have soon operational on our faculty. To conclude the whole presentation, basically one of the ideas of the project was to initiate the mapping process of shallow geothermal potential in Croatia. We kind of succeeded because we managed to obtain results on all 8 locations. We gathered a vast amount of experience and vast amount of data that we can use for further educational and scientific purposes. Also, it can be seen that in the neritic area where rock formations dominate, higher thermal conductivity can be expected. And also use of fiber optic cables for distributed temperature sensing enables us to collect really large amount of data information about the boreholes and for the later monitoring and analysis of the system. Also, all associates in our own faculty equipped with demonstrational units, which will enable us to promote the potential of the technology and to educate the generations to come. And basically, that was the short overview of the project. There was a lot of more story, a lot of more information, but it cannot fit so much in one presentation. So thank you all. If you have any questions, please ask.